When you solve a compound inequality, what you're really doing is solving the exact same inequality 2 times simultaneously, which sounds very complicated, but it's not. You're doing 2 inequalities at the exact same time. Basically what you do is you think about this the same way that you would normally think about any equation or inequality. You say, well, whatever I do to one side, I have to do to the other. But if you look here, we don't have one side and another, we have 3 parts. So the rule then becomes whatever I do in the middle, which is where the variable is, I'm going to do the same thing to each side. So what would I need to do to get k by itself? The objective's the same. I want the variable alone. What do I do to get k by itself here in the middle? Any?
Subtract 3 from all sides.
Right. I got to subtract 3 to get rid of the plus 3. But again, whatever you do in the middle, you do to each side. Some people like to draw lines through the inequality symbols so they remember that there are 3 parts to this. Whatever you do in the middle, you do on each side. Doesn't really matter how you set it up, but I'm going to subtract 3 everywhere. In the middle here, I did that to cancel the plus 3. On the left, I get negative 4 minus 3 to give me negative 7. Got my k in the middle. 8 minus 3 to give me 5. And this becomes my final answer. The task then becomes to graph it. So we'll draw out our number line. There's my 0. Here's positive 5. Here's negative 7. Neither one of these symbols is underlined. Neither one of them is an or equals to. So they'll both be empty circles. It is one continuous inequality, which means that we are guaranteed that they should be connected in between. To get full credit on something like this, you would need to have a solution and a graph, and we have both, so we're all set.